All right, we are 1 minute after. We are live streaming. Hello, you YouTube streamers. And thank you all so much for joining our little workshop on Troubleshoot. We're also happy you could join us. And today, our host slash primary troublemaker, AJ, is going to be leading an interactive dive into troubleshoot.sh, a small yet powerful two-part or 2.5 part, that'll make more sense as the webinar goes along, kubectl plugin that takes the headache out of Kubernetes administration. Feel free to post questions in the chat as the presentation goes along. Or if you like, we can save it up until the end so we can have a group Q&A time. But we are definitely here and we're absolutely super excited to answer all of your questions and to have conversations. If you'd like to follow along, you can find the activity on katacoda.com. I'll post a link to that in a second in our chat. But in the meanwhile, let's go ahead and get this party started. Take it away, AJ. You're going to do awesome.
Awesome. Thanks so much, Shiva. Hello, everyone. Let me try to share my screen. All right. Hopefully, everyone is able to see. Cool. Welcome, everyone, to the KubeCon EU workshop. My name is AJ, as Triba mentioned. I'm one of the engineers here at Replicated, part of the customer reliability engineering team. So today we'll go through two scenarios in the workshop. So the first one will show how to sort of read the support bundles and the logs in the cluster. And then in the next scenario, we'll see how to actually generate these bundles. So if you went to the link which Triba posted, click on the workshop introduction with SB So the goal of this first scenario is for you to just get familiar with some of the tools that we're using and just see how we can use those to actually troubleshoot an existing cluster, right? And then we'll go deeper as the scenario goes into some of the components like analyzers and collectors and so on. So a couple of prerequisites, not really required, but in case if you folks use the VS Code editor that comes with Katacoda, sometimes it might not be as efficient and it might be slow. So I'll do this workshop with just VI and with that editor. But if you folks want to use a VS Code and it's working for you, feel free to use it, right? And just as we go through this, some things might not seem as they are. So just keep your curiosity open, and as we go through it, things will start to make more sense. So here we have a perfectly good cluster, and we'll try to break some things in it, and then let's see how we can determine how we can debug those things. All right, so go ahead and click on the script install trouble.sh. So you'll see an output there. So if you see Charlie Foxtrot is red, it means everything is good to go and the cluster is now officially broken, let's say, right? So just to give a little bit of a preface of what's happening here, we actually are using logs that have been previously collected using our support bundle tool, which will go in the next scenario. And in this one, we use another tool we wrote called SB. It's called support bundle control, which acts as a proxy between the logs we collected and the kubectl commands which you run. So we'll only be running kubectl commands in this scenario. So that is something which folks are familiar with. And then we'll see how this interacts with the logs that we've collected previously. So just keep that in mind. Anytime we run the kubectl command, you're actually looking at these pre-collected logs, right? And why is that? It essentially helps with troubleshooting a little bit easier and quicker. Like rather than asking for a bunch of commands back and forth, it's just easier to sort of use this tool to be able to look at the state of the cluster at the time when it's actually in a degraded state, right? So let's go ahead and continue, and we'll verify that our cluster is actually chaotic, right? So run the kubectl get nodes command, and then we should see, let's see, it takes a second to run, but we should see 3 nodes in there. So you should see CRE troubleshoot 1, 2, and 3. If you see that, it means we have the setup good to go. Cool. Now, what is wrong with this cluster? So essentially, there is a storage component on this cluster which is running. It is not entirely broken, but it's in sort of a degraded state where, because it's a redundant system, we can provision the PVCs and so on. But if another component of it were to go down, then the entire system will go down. So we don't want that. So before it gets to that state, we want to fix it. So let's first get a list of pods and see what's actually available on this cluster. So we see that there are a bunch of namespaces, a default, a kube system, curl, monitoring, rookcef, and so on. So for those who are familiar with the different CSIs, we have OpenEBS, Longhorn, and rookcef is one of those storage components, right? So in this cluster, we are using rookcef. So let's get a list of pods in just the rookcef namespace. So when we ran this, we see that a bunch of the components are in running state and some are completed, although one of them is in a pending state. So this cefmon-b pod is in a pending state. So how do we find out what this could be? So let's go ahead and describe it, and we'll see what the output is. So if we describe it, we'll see in the events log that it's in the pending state because it's unable to be scheduled on a particular node. And this could happen for a couple of reasons. Either the node has a particular label it's missing that the pod is expecting, or maybe the pod has a particular node selector which is not matching any of the available nodes, right? So it could be one or the other. So how do we know what this could be? So let's see what the list of nodes we have, right? So earlier we saw that we had 3 nodes in the cluster. Let's list them out again. So the troubleshoot 1, 2, and 3. And if you folks notice in the node selector output, it's actually pointing to a host name called localhost.localdomain. And in the list of nodes, we actually don't see any localhost.localdomain. So that's probably why it didn't get scheduled. I don't exactly know why. It could be either, maybe our script might have broken something which we ran initially, or maybe the customer did something after the cluster got provisioned and maybe something happened there. We don't exactly know, but at least we've determined what the issue is, right? So let's try to fix it. So in the output, we saw that the node selector is pointing to localhost.localdomain. And generally, we can pick one of these 3 nodes, and then we can update this and it'll get scheduled, right? But the SRE in me, is thinking, well, wait, this is a redundant system. Now, I want to make sure that in the future, again, if any of these components goes down, that one node doesn't take down the entire thing, right? So how do we know actually which node to actually schedule this on? So if you go to the output previously from the kubectl rookcef get pods, we notice that other than mon-b, we also have mon-a and mon-c, which are in running state. So as long as 2 of these are up and running, the cluster is in a good state, but we don't want it to go worse than that, right? So, but how do we know where these are run? So either we can run the -o wide, or we can describe the pod output and see what are the node selectors for each of them, right? So we see that mon A is scheduled on troubleshoot 1. And then mon B is on this non-existent localhost local domain. And then mon C is on troubleshoot 3. So by process of elimination, we can see that, okay, ideally, this should go on a troubleshoot 2. Because if I put it on 1 or 3, in case one of these nodes go down, then that's not ideal. So in this case, troubleshoot 2 makes the most sense. And this is part of a deployment. So let's go ahead and actually edit that deployment and fix this, right? So we'll go ahead and do the edit command, and then let's see the, okay, so this is the node selector, and let's change this to CRE troubleshoot 2, right? And then that should get it scheduled on the right node. Okay, that looks good. CRE troubleshoot 2. Let's save that. Okay. Yeah. Okay, I forgot. So what's happening is we are reading these output that the kubectl is running from a log file, right? So there's actually not a cluster running physically. So even after we modify it, it can't find the resource because, well, all these are just logs, right? There's actually not a cluster running. So it makes sense, right? Why we can't actually edit it. Well, if this was a real cluster, let's say, this would save it and then we'll see it provisioned. But now we can only determine that what the issue is. But let's see, can we do something else? Can we exec into a pod, right? Would that work? So if we try to exec into it, okay, so that does not work either. So as you can see, there are some limitations to this, right? And why is that? So essentially, what we ran earlier, the install troubleshoot.sh, if we cat the contents of it, all it's actually doing is we have a pre-collected bundle. We have sbctl, the support bundle control, which is acting like a proxy. And then that generates a kubeconfig, which the kubectl points to. And that way, whatever you see in the logs is actually you are using a tool which you are familiar with. You actually don't need to know the internals of how like the sbctl is talking with the bundle. It's basically an API server, right? But that's just the implementation details. But ultimately, you can use kubectl, which you are familiar with, to diagnose a state of the cluster at a certain point in time when, or else otherwise, it would be difficult to find that, right? So that being said, we already saw some limitations, right? So we can get things like namespace, and we can get a list of pods, right? All these are available. But if you try to maybe get the logs or maybe get the config map, some of these might not fully work. And that is due to some of these just need to be yet implemented. But the other things like exec and edit, those things, ideally, we would want something at the end to say like, hey, run this patch file or this a deployment YAML and apply it on your cluster. And then you can get the updated node selector and so on, right? So there's still a lot more work to be done in this tool, and it's open source, right? So it's on our replicated HQ GitHub repo. And this is where we kind of need some additional love to bridge those gaps to add some of these features, right? Like, I mean, personally, I would really like to, not only diagnose the solution, but at the end, give either a spec or YAML and say, hey, apply these and it will fix it for you, right? Again, it's going back to the same ethos that you don't want folks to run multiple commands. It's mistake prone. So having some way to automate that would be super helpful. Now, that's cool and all, but how do we get that original bundle, right? Where sbctl is proxying those logs and all that? Well, that's what we'll go over in the next scenario. I'll just pause here for a second just to make sure everyone is okay.
So while we're at a pause, I've been reading through the YouTube comments. They're all positive so far. You're getting a lot of great feedback on your chaos script. So if someone were looking for that, where might they find it?
Oh yeah, it will be in our Katacoda scenarios repo. I'll paste a link for that as well. Yeah, I will. Yep. Let me. I have it in my thing, but yeah, at the end of the call, I'll try to paste it for sure. Cool. And let me see if I can quickly find it. Yeah,
I got it. I just put it in chat.
Okay, cool. Awesome. Thank you, Triba. Cool. Yeah, it's just a simple script. It's a lot of craft. I try to, be a little fancy, but it's literally one line which will execute it. But yeah, nice. Awesome. So now let's talk about how to actually generate that elusive bundle, right? Now, how can we get those locks and stuff? So the support bundle is divided into three things: the collector, the analyzer, and the redactor. So we'll go through each of these and see how we can use these to gather information about your cluster and your application, right? So first things first, as this is loading, we'll install the binary where this support bundle is installed upstream, and then we'll install it locally on this cluster, right? So, and we also have this available on crew with a KREW, the Kubernetes the plugin management. So you folks can, if you already have crew installed, you can do that as well. But in this case, I'm gonna download it directly from our repo upstream. So if you just click on it, it'll download the bundle, the tar-gz, which is just a binary of support bundle, and we'll untar it. And this is what we're interested in. And then I'll move it to an executable location. This can be anywhere in where the kubectl can actually read. So this naming it matters. So that way it can be used with the kubectl command itself directly. So let's see if this is working. So you need to give some sort of a parameter or else it will error. So here we'll just try to get the version and see how that looks. So the version is 0.301, and ignore some of these warnings we might get as we run through this sometimes in the cluster, and we'll see in the next step why that is. So some of these, because the resources don't exist in the cluster, it'll just give a warning. But the reason for this is when we create the support bundle, by default, we don't actually mention anything in the spec. So in the spec, we just have the blank collectors and analyzers, and this is just in YAML format, right? So the YAML format will just allow us to collect the basic information about the host, about the cluster, and so on. So again, if the IDE is working for some of you folks, try to use it, but I'll recommend to just use VI wherever possible, right? So, so I'll create a file called support.yaml, and I'll paste this, right? So essentially, we've, even though we've defined empty collectors and analyzers, because in built, we have a couple of collectors about the cluster, it will get things like about the host, about the deployments, PVCs, and so on. So let's run this. It'll take about 20 seconds for this to run. And what the collector is basically doing is it collects things like logs. It will exec into pods and run arbitrary commands. If you want to collect a config map or some sort of information within the resources in Kubernetes, there are a bunch of collector resources which you can use to collect this information. And then analyzers are then run on top of that. So in the analyzer, you can set a bunch of thresholds to either fail, warn, or pass. And based on the collector output, it will then show whether things are in a state where it's acceptable, right? So now we ran the bundle, and if you notice, it generates this arbitrary timestamp depending on when it's ran. So just to keep things simple, I'll create custom directory and untar the bundle in there. So if you visit inside the support bundle data directory, we'll see a bunch of folders and files, the cluster info and cluster resources. So cluster info will have the version related information about the cluster, and the resources will have the deployments, pods, namespaces, those kind of things. And we'll go into detail what each of these components are actually. So if we go into resources. So don't worry about trying to read all this. We'll go through what each of these mean, right? But just know that even when we have nothing defined, it still collects a lot of information that could be useful. So just, let's keep that in mind. And if I try to cat this, we should see, the version of the cluster of this Katacoda cluster where we are running. That's the version it's running on, and that's what it shows us. And just to reiterate, yes, you can run all these manually, right? You can run a kubectl version and then a kubectl get pods -o YAML, but that's a lot of back and forth, and giving that many commands to support engineers and have them run if something fails, and it's a lot of time wasted, especially if folks are in different time zones. The feedback loop is going to be very long, so having the ability to define these beforehand and just having folks run a single command is very useful. And we'll see how to build on this in the next step. So we have launched an app which is currently in the process of being deployed on this cluster. So we'll give it maybe a couple of minutes. Basically, it's an app in the namespace Trouble, and it has a couple of pods with the label app equals Trouble. And we'll try to use the pod logs collector to gather some basic information. So essentially, this selector is saying, hey, any pod with the label app equals Trouble, collect the logs from that, right? So let me create a file called trouble-1.yaml. And let's save this. And before I run that, let's make sure that it's okay. So you folks should see a namespace called Trouble. So mine is 54 seconds. So if you don't see that, you might need to run this install trouble.sh script again. But if anyone is unable to, just let me know. But basically, now we can run this support bundle and try to extract it. So let's go ahead and run this again. It'll take a few seconds. And while when this is done running, we should see a little bit of difference in the folder structure, right? So we'll see the general cluster info and cluster resources as well. But if we ls this, we should see a new directory in there as well, a trouble-app. So before we didn't have that, and now we do. So in this, we should see a couple of files. These are essentially the logs from the pods from the trouble namespace with the labels app equals trouble. So let's cat these ready and see what kind of logs are in there. Hopefully we'll find some interesting ones. Okay, nothing interesting in there. Okay, maybe in the previous. Okay. I think the other pod is provisioned. Okay, hold on. Let me try to find. Okay, that's odd. Okay, apparently none of the pods collected like the logs. So we see the files, but there are no logs in there. So but we do have other logs, right? So if we go into this cluster resources, so if I do, let's say, earlier we saw this list of directories and folders, right? So what are these? So essentially, each of these directories are resource types. So the deployment type, events, ingress, jobs, so on, right? And inside it are the actual resources separated by the namespace. So if we do deployments, we'll see that we have the default kube node, trouble, and so on. So the namespace command we ran earlier, if we run that again, we'll notice that for each of these namespaces, there's a file. So it does that by default for all resources. So even if we don't collect the logs, we'll at least have some things we can, go over, right? So with that, let's see in this trouble JSON deployment, like if we can find any info, right? So if I, copy this, I mean, not necessarily need to, but if I grep to see what could go wrong, let's see like if any of these actually was provisioned, right? So if I look at, okay, so we see that from the deployment status that neither of the pods are available, right? So it's expecting 2, but none of them were provisioned. So if we, and that, if you can verify this, so if we run, we see these 2 pods in pending, right? And that makes sense. That's why it's saying it's unavailable. Now, why could this be an unavailable state? Generally, you would look at the event log, but here, if we, instead of deployments, if we do events, and let's see, let's look at the nodes, right? So we see that the reason it's unable to be provisioned is because it's a similar issue to the last one, where there's some issue with the node selector, right? In the last one, the issue was the nodes were fine, but the deployment was incorrectly using a selector which did not even exist, right? But in this case, it could possibly be that the node might not have a label, right? So let's see how to determine like what this could be and how we can sort of fix it. And we will try to fix it, but before we try to fix it, we also need to sort of think about, well, what if this issue happens again in the future, right? So you might be a Kubernetes expert, you know where all the logs are and all that, but say a support engineer runs into a similar issue. Now, for me itself, I've been doing this for 3 years now, and I still get confused like where these logs are, and no one likes to read JSON files, right? So it's, and you want an easier way for them to surface this. So let's see how we can do that with an analyzer. So we still have a broken app, but we will try to now surface the same issue in a more interactive way. And to do that, it turns out that the node which you're trying to provision, it is an issue with the label on the node. So unlike the last issue, this time the deployment has the right labels, but the node is not matching any of those, right? So how do we fix that? So let's write a new spec where we'll have not only the collector, which we had before, but we'll also have an analyzer, which will surface what this issue could be. So I'm going to copy the spec again, and we'll create a file called trouble-2.yaml, right? So, and then we'll save it. And then while the app is still broken, let's run this. So it's going to collect the same logs, but then on top of these logs, it's gonna run these thresholds. If the label is not matching any of those what it's expecting, it'll say at least one needs to be available for it to be ready, right? So here, similar to the node resources, we have a number of other type of analyzers as well, which you could use. But in this case, we are saying, okay, at least one node should match this label. And right now, no nodes in the cluster match this label. That's why it has a red X, and that's why it's failing. And that's why our pods are in pending, right? So now that we know, and we're able to do all this, by the way, without catting anything, without untarring anything. So as soon as we run it, we'll see that, okay, this issue. So this saves a lot of time. Imagine you have like hundreds of collectors and analyzers. So, you can see how this could be useful, right? So now that we got the bundle running, let's try to fix this by adding the label to the node. So we'll add the super GPU label, and then let's give it a few seconds to see if one of the pods at least isn't running. Okay. So as long as one of these is up and running, it's fine. You don't necessarily have to have both running because this is a redundant system. It's okay as long as one of them is running. But now that we fixed it, what would this look like with the same the spec which we wrote already, right? So I didn't make any changes to trouble-2.yaml. With the same spec, I'm gonna run that again. Only change we made was adding this label called super GPU to node 1. So let's see now how it looks differently. Okay, cool. So before this had a red X and now it's passed because we added that label. Now it's able to provision and we have this check pass, right? So that's pretty useful. That being said, we do have one other issue, and I'll show that while I untar the bundle. So let's untar it. And if we look at the logs, let's see now if we have any logs, right? So if we do support data, so it depends. Sometimes you might have a dash in the directory name. Sometimes you might not. So just pay attention. Like I generally a tab completed. So just a heads up on that if the name is different. But in here, we have a bunch of files, right? So let's look at these different ones. So if I look at this is basically the names of the pods from here, right? One is pending, one is running. If I look at the running, I mean the pending one, okay, there's nothing there. Let's see if it had any previously. Okay, nothing there either. Probably because those weren't pending, that's why. But let's see one of the running ones, if that is any better. Oh, great. Awesome. Okay, cool. So we are finally able to see some logs at least now, right? So that's good. So this means that once it's able to have the pod running, then it's able to see the output and then it's able to collect the log. So while the pod is in pending, it's not able to do anything because it's not even launched, right? So where will the logs be? But if you folks notice, the secret though is not redacted, right? It's out in plain open. Now the star ball is not any encrypted or anything. Anyone can untar it. Anyone can see the contents of this, right? So this is not really ideal, especially when you want to share these bundles, outside of the environment. You don't want the sensitive information to be out there, right? So how do we actually go about fixing this? And I just want to mention, it's not only in this one file, right? This could be in any number of places. So where we ran earlier in the resources directory. So if we do the go to this cluster, resources, pods, trouble, and then you grep for, let's say, the secret. So we see that even in the configuration, we have these secrets. And this is not good at all, right? Because it's in multiple places and it can get compromised, and this is not good. So generally as a support engineer, we will tell the devs that, hey, how can you fix this? How do we avoid these logs being collected? But what would be ideal is if we as support engineer could actually redact some of these and not put the burden, on them, right? So how do we do that? So the redactors are essentially, if you have sensitive information, and not only API tokens like username, password, or any other sensitive information like IPs, which you don't necessarily want to be exposed, but you want the information around it to be shown for context, right? So it'll be super helpful. So we'll take almost the same the spec as before, like the collectors, analyzers, and we'll add a new one called a redactor as well. So let's copy this. And let's name this trouble-3.yaml. Okay, so we'll do, let's do trouble-3.yaml and then save it. Okay, So now we have all three. We have a collector, we have an analyzer, we have a redactor. This is our final spec, if you will. So I won't use the interactive flag this time, and instead just pipe it to jQuery so that we can see the output and how that looks like. So this will then again run the same collectors and analyzers, and the analyzer, it will show in JSON form, so that it's easier for us to read. But once the bundle gets generated, we'll go through the same files again. So if you go up in your output there, and if you cat the same log file, but in the new bundle, we'll see that now it's hidden. Same thing with the JSON as well. If we try to grep that, now all that is hidden as well. So each time you run the bundle, the result might be different. And that's really one of the advantages of this. So as you are fixing stuff, you know, okay, what has the status been and what was the issue, like how it was fixed. And then you can also sort of get that a feedback loop very, very quickly, right? So it's very helpful that way. And this way, you as a support person can write these redactors without waiting on the dev to like, hey, can we like remove this information? You know, anyone can write the redactor, even the end customer. Say, apart from these, they have additional stuff which they feel like, no, I can't even send it to my own vendor. Okay, they can write their own the spec, add additional stuff, and then run the kubectl support bundle again. So it will not only run your spec, it will also run their spec, and then you'll have, you know, a holistic bundle. So yeah, if you've gone this far, thanks for going to the workshop. So that's in a nutshell how, you know, you troubleshoot the Kubernetes clusters with the various tools.
Hey, Jay, we had a question come in.
I'll hand it off to Chris, and yeah, he'll
right before you do, AJ, we had a question come in that
okay.
you won't be able to see on the YouTube live stream. So I'll just read it off real quick if you want to. I
Sure.
typed in an answer here, but again, they won't be able to see that in the live stream. So the question was, does support bundle need to execute into pods? And does that mean that you need to tweak things like network policies that are in place for it to be used?
Yeah, so you do need, depending on the user that is running the kubectl command. So if your context has access to these pods and you're able to use it, then a support bundle will run as well. But if the context does not have access, then yeah, you need to give additional RBAC and network policies to actually get that to work. A good question.
Were there any other questions in the either the YouTube chat or the live stream here before we move on?
Oh,
there was a question in...
yeah.
Go ahead,
Can you run on completed pods? Yes, yeah. As long as the pod is available there and the logs are there, yeah, you can run it on completed pods. And also with the newer Kubernetes versions, some pods are in like a shutdown state. This will work in that as well. So it'll solely work on those label and things. As long as available, it will be able to pull. Awesome.
Okay, I don't see any more. I'm going to do just a quick, I guess, exit here. If you do have more questions, feel free to drop them in and we can come back to those as well. There we go. Is my screen share working? Able to see my screen?
Yep.
Awesome. Just a quick exit here I wanted to address. AJ here is part of Replicated's customer reliability engineering team. So if you're wondering who's making these tools, why does this exist, how are we doing this out in the open, just a brief description of what this team is and what we're doing. So the customer reliability engineering team here at Replicated, we support the lifecycle of applications on Kubernetes. We work across all the major Kubernetes. We work across a lot of different vendors in a lot of different industries. And we're looking to build open source community and tooling to scale best practices and code. So tools like Troubleshoot that AJ just went through today that help us and really anybody work better on Kubernetes, work faster, identify issues faster, and just make things easier to deploy across any number of environments. It's a really good role if you are really interested in deep Kubernetes experience, deep Linux experience, and open source development. So this team's going to see a lot of different Kubernetes clusters with a lot of different applications and architectures, some small, some big. And we're going to be working on tools like Troubleshoot, typically written in Go. So if you're a Go person, that's what most of our tools are written in, as most of the community is as well. Troubleshoot is an open source project. Most of what Replicated does is open source. So you are welcome to come and contribute as well. So I think Triva has posted already in the chat a few times, but the troubleshoot.sh website is the public website for Troubleshoot. We do have community meetings, and the code is right there available on GitHub. So you can come interact with us at community meetings. You can come interact with us on GitHub if you're interested in helping with the project. Additionally, if you're interested in helping with the project, and this all sounds like something you'd like to be doing on a more permanent basis, we are currently hiring for this team. So if working with Kubernetes, either from a Go background or a Kubernetes background, if either one of those sound like experience you have and you're interested in gaining the other, come talk to us. We're at KubeCon. I'm not there today, but we have several people that are in person or attending virtually. And you can also find job listings on the Replicated website. You'll find the two I'm showing here on our careers page. They both say customer reliability engineering in them. One says Go, one says Kubernetes. That's just to let us know what your background is. They both work on the same team. We want people that are good at coding. We want people that are good at infrastructure and Kubernetes and working together to build those tools to make things easier. This particular team is hiring remotely in US, Canada, UK, Netherlands, Australia, and New Zealand. So we've got open positions in all of those regions today. If you're interested, if you go apply to one of those jobs, I'm one of the first people you'll talk to. So please come talk to us if it seems interesting. And if you're not even 100% sure, but you want to know more about what we're doing and how we're building tools and what that looks like, come talk to us, see if it's something that interests you. Or come hang out with us on the Troubleshoot community meetings and with the GitHub, and you can contribute even if you're not interested in a position. All right, did any other questions come in that you want to address, AJ?
Oh yeah, I answered a couple. Yeah. If anyone has any questions, yeah, I can stick around for a bit, yeah, and answer.
We got one from Niles. Are there any limitations to what an analyzer can do? And can I write analyzers which are leveraging metrics?
Yeah, so definitely we've used analyzers to collect or to do things like gathering Prometheus metrics and then running analyzers on top of that way. And limitations today are you might see that you will end up using like the regex analyzer a lot, right? So, and we do have a couple of other analyzers as well, which look at things like here I'm getting a list like the cluster version, like the node resources, general status of the cluster and so on. We also have things like you can get the state of MySQL pod, right? So if you give a node selector, limitations are if there is not like a written a selector for something, you might have to leverage the regex collect to write it. But the good thing is, once you write that, you can also contribute to the core as well, where we can actually have an analyzer built in so that we don't have to write the regex to make that happen, right? So yeah, that's one limitation that I find today.
Awesome. Thank you so much for that great question. And thank you, AJ, for answering twice. I saw you answered in chat also. One last question. Christoph is asking over on YouTube if we have a link to our slides to share. I guess I'll go ahead and take that one. So, short answer, yes, but um, we're having a little bit of a challenge with sending links through YouTube chat. So if you could ping oss@replicated.com, I'll make sure that you get those. All right, so any other questions? This has been awesome. Great, been spending time with you all. All right, going once, going twice. I hopefully will see you all at our next troubleshoot meeting. I'm expecting you all to be there. But thank you all so much. This has been amazing. I hope that you have an amazing KubeCon, and I look forward to seeing you involved in the troubleshoot community in the future. Have a fantastic rest of your week. And for those that are over in Spain, lucky you. For those that are at home, lucky you too. It's good to be able to stay at home. But you all have a fantastic rest of your week. This has been a pleasure. Bye, everybody.
Bye, everyone. Thank you so much.